Oh, what a day! What a lovely day!
Welcome to Flat Earth Debate Live. I'm your host Nathan Oakley, and if you are new to this channel, or you've not done so already, then be sure to subscribe, hit the bell notification icon and join button if you'd like to become a Nathan Oakley 1980 channel member and keep up to date with the Flat Earth Debate. If you'd like to support the channel, there is a super chat that runs alongside each of these shows while they're live. There's also a PayPal, Patreon and crypto link in the info box below the video. Most importantly, if you'd like to join the discussion right here, right now, simply mute the page you are currently watching, then click the link in the info box below this video to join the panel and express your views on the nature of Earth. If you do join, please don't swear. If you do, you'll be ejected, and if you are, please don't try to rejoin the stream using sock accounts. You'll be warmly welcome back on the next stream. Please also share the show on social media. Sharing the show obviously increases the live audience, but this in turn increases the chances of a more diverse panel, so please share the show on Facebook and Twitter. And one last time, if you're new to the channel or you've not done so already, then be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth Debate. Now, before I introduce who we are joined by, I'm going to do a few quick shout-outs to some of the Nathan Oakley 1980 channel members who are hyenas. So shout-out to Ali B, Lite Energy, Rakia Life, Unicorn Laser Eyes and Dal West Watson. Massive shout-out for being a Nathan Oakley 1980 channel member. As I say, if you do want to join, there is a join button or a link below if you're watching on a mobile device. Now, we are joined by Flatzoid, Paul Hall, Chocolate Saiyan, 10th Man, and a whole bunch of people in Discord. So welcome one and all.
Good Friday to all.
Hey, hey, hey.
Good morning.
Good morning. Good morning, good morning. We've got a presentation by Babs, which we're going to do as soon as we get through with housekeeping, so hopefully we can rattle through this fairly quickly. Any signs of a physical geometric Earth curve obstruction capable of measurement?
2 words. Nope. Black Swan.
Any signs of any Earth curvature of any description?
Not from Point Magoo.
Any evidence of...
Point Magoo? Is that a real place?
It sure is. Just north of Malibu.
Nice.
Any signs of axial rotation?
Africa is flat.
We'll get there. Any signs of axial...
even
Go on, Flatside. Or leave a massive gap when I clear the airwaves for you. One or the other.
I say even globers these days claim no axial rotation because there's no geometric shape.
Right. Got to have some geometry to have an axis. Any evidence of the distance to the sun?
No, they can't even get the horizon near it. So how are they going to do the sun?
Hey, Arwin.
Hello. Good afternoon.
Good afternoon.
Bizarro Legolas. What's up, man?
Yo, Chocolate Swan.
Any scientific evidence of
What's up,
gravity?
man?
No.
I haven't asked this in a while. What's gravity?
Bending of a conceptual medium known as space-time.
Bending of a concept. How do you bend the concept again?
You can't bend love. You can't bend freedom. These conceptual ideals aren't to be bent physically. It's nonsense.
Well, the only way to bend the concept is conceptually bending it. So everything you're going to do with the concept, you're going to do conceptually. So you can't really thread outside of the medium of concept after that point on.
It's kind of like bending the spoon because the spoon isn't really there. Something like that.
That's
So it's
really
not.
good.
It's not the spoon that bends, but yourself. Gotcha.
Any evidence of a self-perpetuating molten iron core at the centre of a presupposed spherical Earth?
Beyond any paintings in encyclopedias and toolbox. That's really the most where I see the concept in the first place. Now they updated it a little with some CGI here and there, but still nothing beyond that.
Just look inside. You'll see that it's not the core that self-perpetuates. It is in fact yourself. Shout out to Paul Hall, who's on the panel. Wants one to rule them all. Right on. Any viable hypothesis from any of the fields of astronomy, cosmology, or astrophysics?
No, otherwise I thought one. Otherwise, someone would have been on your mind now.
Right on. You think someone would have some science? Any evidence of the R value, Earth radius?
First, need a sphere to have a radius.
Last but by no means.
There are signs of a radius of about 260,000 miles, but there's not of a 3959 miles. So we're supposed to live on the smaller one. So I don't know.
Very nice, Chocolate. I like the way you weave that through.
Right. So I think the other one's slightly a little bit off. So I would go with there's no actual geometric horizon.
Hang on. Wide Awake did a video 28 inches off the ground and caught over 11 miles. So that 260 some thousand just grew.
Oh, damn. That's a shame.
So we're going to get, as I say, a presentation from Babs after the last housekeeping question. So any evidence that you can have gas pressure without the necessary antecedent of a container for all those fundamentalist religious zealots who believe the sky is a vacuum?
I'm going to respond like this.
You're dying because the sky is stealing all the air.
Exactly.
No, we're all good. We're all fine. We've definitely got gas pressure here. We're all breathing it. All right, so Paul's screen is presented. Babs, do you want to do a quick check, see if we can hear you okay? Slick.
Check. Can you hear me?
Yes, we do, yeah. Okay, so in your own time, you've all presented A, B, and C.
Excellent. So basically what I'm going to go through today is just describe to you what meniscuses are and what conditions are required in order to form a meniscus. So a meniscus is the curve in the upper surface of a liquid close to the surface of the container or any other object caused by surface tension. It can either be concave or convex, depending on the liquid and the surface. So a concave meniscus occurs when particles of liquid are more strongly attracted to a container than to each other, causing the liquid to climb up the walls of the container. And conversely, a convex meniscus occurs when the particles in the liquid have a stronger attraction to each other than to the material of the container. So as you can see in this image here, A being the concave meniscus, B is the convex meniscus, and C is a neutral meniscus, which happens when I believe there's an equilibrium between the amount of attraction between the particles in the container, which results in a flat meniscus. So if Paul could go to the next image.
Yep.
Right, so this is what it looks like in real world. On the left, we have mercury with a convex meniscus, and on the right, we have some transparent liquid, which I believe is water, which has a concave meniscus. So why am I bringing this up right now? It's related to something that was presented yesterday that I want to just go into really briefly right now. It's a demonstration that was done. Did you get the video that I sent you, Paul?
He's on mute at the moment because he's presenting.
Yeah, I've got it. I just have to jump between screens to get unmuted, so I do have it, but I'm gonna scrub it. So just for copyright issues. So hang on.
Right. I mean, you don't have to play the video. You can just show screenshots.
Gonna make a very quick comment, just 10 seconds.
Just keep it to the end, Darwin, I beg of you.
More like a question, but
Just keep questions till the end of his presentation. Let me know when you're ready,
All right.
Paul.
okay.
I think we're ready.
If he could get it to the 15-minute mark. Okay, excellent. Right
And
there.
also make it full
So
screen.
what we have here is we
I'm
have
sorry.
a
Can you make it-
ceramic bowl.
Perfect. Thank you. Sorry, Babs, go ahead.
Okay, perfect. So what we have here is we have a ceramic bowl, and inside this bowl we have water. So the water has been filled to the point that it's at the brim of this bowl. So as a result, we end up with a convex meniscus on the surface of this water. Now, on the other side of this bowl, a small light has been placed close to the edge, and by slowly lifting the camera up, we can see that that light is obscured to some degree, but it's being obscured by the convex meniscus of the water. Okay, so we can move away from that video now since we've demonstrated that point. And now if you could share the last image that I sent you.
Perfect.
Excellent. So that demonstration was used to say that in Life is Short's presentation of bottom-up disappearance, pretty sure most of you have seen it, where he has an object that's being viewed across this pond, and he's able to make it get obscured just by slightly shifting his angle of view. What they're trying to say is they're saying that the surface of this water has a convex meniscus that is obstructing what we're observing. And because we're reducing our angle of view, the meniscus is sort of curving or overlapping what we're looking at. And I just feel like that's not really analogous to what we're looking at here, because we're not looking at a container that has sides where the water is sort of interacting with it. Perhaps we are, but it just hasn't been explained to such a degree where it's analogous to what we're looking at before.
I see. So what you're saying is it would require somebody to actually demonstrate on a very wide, even if it wasn't that wide, maybe a metre or two surface area for the water to sit on, how much of a meniscus, if that's the right terminology, on either side you have. In other words, is it 3 inches, or does the entire 2 metre bowl have a very linear curve from one side to the other? I would imagine that it would dip down at the most half an inch on either side, and then essentially be flat and level all the way across to the other side until it dips down again. No, would it be dipping up with water from what you just said? Yeah, dipping up, going up.
Exactly, and at the moment, all we have is just the demonstration at a micro level. We don't have it at a macro level to show that it actually works.
Well, I'm sure it would. I'm sure. I mean, no doubt at all that you'd have a, this. You're talking about stuff that's got very weak intermolecular bonds. Water's not very strong bonds between the molecules. The intermolecular bonds are weak. But nevertheless, that's why you can have this effect. You can have a stronger bond with something on the side. Well, that's not going to translate to the stuff in the middle of the pond, though, is it? It's only going to translate to the stuff right next to, where the bond with the physical molecule that it's right next to is going to be stronger. And that will obviously get weaker and weaker as you go away from the sides until you reach, I would imagine, like I say, about no more than an inch into this pond, and then the effect will have gone. Because you've only got the bonds with the water itself.
Exactly. Exactly.
Arwin, did you have a comment, Arwin?
Well, yeah, I thought that the mechanics behind these effects, this repelling and attracting, it's also at the core of the capillary working, and like entire plant world survives basically on that concept, on water being attracted to other matter and then having a tiny channel in order for it to be drawn up without any external forces necessary, and then keeping it going. It's mechanics of nature. And water is typically attracted to a lot of things, while, for example, mercury is not. It's not attracted, so it's going to be a lot more attracted to itself than the surroundings, resulting in a typical more a convex setup. While water will typically result in a more concave setup because it is going to be attracted to the sides.
Sure. Can you
Unless
put that
it's
slide
like
up?
an overfull plastic bucket.
Yes, perfect.
That's like
Can you put that slide up, Paul, if you may? The one with the mercury and water showing convex versus concave meniscus. Not that one. That one. That's it. Perfect.
Exactly, Arwen. The results are kind of related to the intermolecular bonds between the molecules. That's what creates the effect that we see.
Bonds between molecules is inter. What are you guys talking about specifically?
We were talking about how some people think that in Life's short video, the obstruction that he's showing is due to a convex meniscus on the surface of the water, not due to a diffraction limit.
That's retarded.
That only works when looking over a bucket of water that's overfull.
Hold on.
I mean, this only occurs in like something like a test tube or a bottle, or I mean, you probably could have one in a bucket.
Yeah, I think that's his point.
Right, but you can't have that in an ocean.
Yeah, but that's what your side's claiming.
No, it's not, Nathan. It's demonstrably true because think about it, right? You have a beach, right? You do not have a container where a meniscus could form.
Sure, in this instance, I think it's because it's in a pond. It's actually like a hole in the ground as opposed to a beach.
Yeah, in a pond. If the walls were the perimeter of the pond were like walled off, like maybe like a canal or something, then I suppose you probably could have a meniscus, but it would be undetectable because you can't raise a pond to eye level, right? You can't get. I mean, unless the walls of the pond were like perspex or glass or something transparent, and then you could get down to see because you need to bring the meniscus up to eye level to see it. So for all intents and purposes, it would be undetectable.
Well, I'm glad you agree. Cool.
Oh, cool, right, okay. So I was going to. Would you guys be okay? Well, Nathan specifically talking about this QE Black Swan thing and what I think of it.
Of course, yeah. By all means.
Right. So now I know you heard me on 24/7. I was a bit ill prepared, right, and they asked me to state the argument. I knew the argument, right. The argument is, right, it's on a globe. We can see no farther than the geometric horizon. We see no further than the geometric horizon, therefore not a globe, right?
Well, now, we see further than the geometric,
as it's been pointed out several times, the consequence of the first premise is false, right? It's invalid.
Which premise would that be?
Right. So the first premise is on a globe. You can't on a globe of for a radius of 3. Is it 39? What's the radius again?
3959.
3959, Chris. That's your model.
Right. 3959 miles. Right. That's the antecedent. That's the antecedent, right? Then on a globe with 3935 mile radius, then we should see no farther than the geometric horizon, right? And then it gives the math for that, right? That's a consequence of the first premise. The consequence of the first premise was backed up by a source. Let me. The QE has since, but never.
Sorry, the source is just Earth-based geometry.
The source was from aty.sdu.edu explain atmospheric refraction horizon, right? Andrew Thomas Young, San Diego State University. Right.
I mean, he might have been referenced, but as I say, sorry, I just want to correct this. Sorry, Chris, bear with me. I just need to correct this. Chris, can you hear me? Can you hear me? Hello? Can you hear me? So,
I'm sorry, yes.
So that may have been what was cited specifically to give a reference. for Earth geometry, but it's not required. It's not hanging on that citation. It's just Earth geometry. It's standard model.
That's
you
correct.
can get the same. I'm nearly done. You can get the exact same geometry from the standard model if you wish to do so from Mick West or any source that claims Earth's a sphere, because it's the standard sphere geometry. It's not Andrew Thomas Young that's giving us geometry. It's just the Earth's geometry.
Right. But,
So are you saying, Chris, that that's not the radius of
Hold on,
the
Chocolate.
supposed Earth?
Hold on,
please let me
Chocolate.
respond.
Go on, Chris.
Respond. So, Nathan, if my mic gets a bit wonky, let me know. It's Bluetooth. I need to reconnect it. Right. So, you're right. It isn't just Andrew Thomas Young that's saying this, right? This is just spherical geometry, right? Doesn't matter. Excuse me. It doesn't matter really the size of the sphere. But in this source citation or reference or whatever you want to call it, that he used to support the math, right? The 1.23 miles times the square root of the observation.
Didn't I just correct
that
this?
same page?
Sorry, Chris, I just corrected
Right,
this and you've just
but that
ignored
same-
me. Sorry, Chris. You've just said this source or citation or whatever you want to call it used to back the claim. No, I've just explained that literally 2 minutes ago. It's not being used to back the claim. It's being used so you can reference Earth's standard geometry. Don't need this citation. It's irrelevant. Useful if you want to go and reference it, but it's not hanging on anything. It's the geometry of Earth. Simple, plain, doesn't matter. You don't need this citation for Earth geometry. It's fairly standard stuff.
Right. But Nathan, my point is that he used that source to support the math, right?
To back?
That's the reason
No,
he
I'll
added
say it third time. He's not using it to back it. It's standard Earth geometry. He doesn't need Andrew Thomas Young to back that Earth has a geometric radius of 3959. It's standard geometry. It's not backing anything.
Okay, so why did QE include?
Because he likes to give citations so people can go and check he hasn't just made up a bullshit radius value.
That's right. But on that same citation, it goes, the very first, the very first sentence talks about geometric horizon and
on that citation,
horizon, right?
Sorry, you said on that citation. That was what he cited, was it? So that's the part that QE used, was it?
No.
So that's not his citation. Stop.
That's right.
Stop. So it wasn't his citation then. Do you know?
Right, but my point is, Nathan.
I don't stop.
Nathan,
Stop going on with. Why is it that you say right and then you completely ignore what I've just said to you? Like, yeah, I acknowledge what you've said. Let's now completely ignore it and talk indefinitely over it, having just ignored it. You specifically said his citation and then read the first line of the webpage. I asked you if that was what he cited, and you said no. So, are you now misrepresenting what QE's actually cited? You lying bastard! Shut up! You lying piece of shit! Now, one of two things is true here. Shut up or I'll remove you. Either you're a lying bastard who's just misrepresented what QE actually cited, or you don't know the difference between a reference and a citation. Which is it? Lying bastard or dumb as fuck?
Right, if you'd allow me to explain, Nathan. Right, so the reason in the comment that you left on Panto's video, the reason I said that what John did was special pleading and cherry picking is because he ignored all the other things from his source, right?
You stupid retard! You don't know the difference between a citation and a reference.
I'm not.
Oi!
Right, okay.
I listened to you, now shut up!
One last thing.
Why are you talking? I listened to your bullshit about cherry
Because I
picking.
wasn't done.
Shut
Because I
up!
wasn't done.
Shut up! I listened. I heard what you claimed. Now I'm responding to it. Now shut the fuck up! That is not cherry picking. You have misrepresented him because you're dumb. Not a liar, just dumb as fuck. And have said that he cited something which he did not cite. You've then gone to the start of the reference and started rattling off things he didn't cite, claiming he's cherry picking, when in reality, you're thick and don't know the difference between a reference and a citation, and have then gone to the reference he cited from and cherry-picked new citations, claiming he's got them as citations. You're thick!
All right, so I'll give you a more...
Not all right! You dumb, stupid shithead! You are incorrect! Not all right, you stupid retard! No, you've misrepresented Quantum Eraser. Why are you now talking? It's not all right. You've misrepresented him. You've made out like he cited something he hasn't, and then confused references with citations, and then claimed he's cherry picking. Wrong! You're unbelievable bastards. Why are you still talking?
Because you've already said that. You're just repeating yourself.
Yeah, and I will, because you said right, like it's okay. No, you unbelievable piece of shit! It's not okay! Misrepresenting another man based on your fucking stupidity. Telling me that he's cited something he hasn't, and then claiming he's cherry-picked because you've cherry-picked. You pricks! And then you think it's necessary to talk over me and concede it like it's alright? It's out of order! It's not alright! You are misrepresenting him! You prick! I'm trying to turn that misrepresentation into an argument. It's not.
Right. I'll give an argument. Right. Okay. So if P.
This was the same nonsense you tried to pull on 24/7.
Right. If P, then QE's P. Nathan drinks. Conclusion. Yummy, yummy, yummy.
Fuck off. That's another ad hominem. So three times in a row when they get their ass handed to them, they just deliver an ad hominem attack. So he's not addressing my argument. He's not addressing his fallacious use of cherry-picking himself. When misrepresenting QE as having cited something, he didn't go anywhere near. He doesn't understand what a citation is. He's thick. Yeah, he wants to come here and accuse me of drinking piss. That's the level of rebuttal. Pathetic. No apology for his total and utter disregard for the actual representation of his opponent. Misrepresents it completely, and then accuses him of the fallacy he's using. They've all got the same repertoire.
Yep.
Yeah, I would agree. That was pretty pathetic, Chris. Any other ballers can do a little bit better than that, maybe. Maybe a little bit more adult.
The problem is all these keyboard warriors trying to say something when they can. They've got no clue how to actually debate.
I may have a reason, an explanation as to why some of these people out there are just getting worse. It's just post-Swan depression.
I agree.
I agree. This is leaving them in a lot of cognitive pain. It's just pissing me off that they're projecting it onto me and QE constantly.
But as soon as they say the first premise is wrong, they're saying the radius is wrong. Am I right? Am I getting that right?
I mean, that's what I heard. That's why I asked it. So, what's your radius then?
You want me to give you his argument?
If you're saying the first...
I want to give you his argument because I understand his argument. He's saying the second premise, the Q premise, every distance to horizon measurement must be no more than 1.225 times the square root of the observer's height in feet. He's saying no, because every distance to horizon measurement implies that it must be geometric. It's a geometric model. But they're saying, oh, no, it's refracted. And like Brenda, I go, well, it's not geometric then. And then they have a little cognitive break where they go, fuck, I need a geometric horizon. But I'm definitely telling them we haven't got one. This doesn't quite add up.
Yeah, but even when he was trying to recite that, he didn't even really say it right. He was talking about seeing beyond the geometric horizon, but it's really the distance measurement.
Yeah.
So, I don't know. I don't think he understands the Q part. Because I've heard him before, and on that 24/7 thing, what he was trying to say is, oh, we don't, it's a straw man because we don't believe that every horizon distance measurement can be no more than 1.225 times the square root of the observer's height in feet. But it's not about belief. That's the geometry of the ball.
Exactly.
So
if you disregard the second premise, you're disregarding the ball. Precisely, Chocolate. If you disregard that every distance to horizon measurement must be no more than 1.225 times the square root of the observer's height in feet, then you deny that we have a geometric horizon and it's an absolute necessity for the model. They just don't get the argument yet. As soon as they deny the geometry, they're denying the geometry. But they don't realise it, they're just too stupid.
Well, and as soon as they change it from from geometric to a refraction horizon, that's actually what they're doing, right? They're not. The geometric horizon should be so far out, but if they say, well, that horizon's refracted, then it's not a geometric. So yeah, okay, I get it.
Yeah, they're screwed at square one. That's the point of checkmate. As soon as the horizon isn't geometric, that's the basis of their religion. So them fighting for it not being geometric, it's like, yeah, you've still got a geometric horizon in your geometric model with a little x and horizon written next to it. So then you have the morons that appreciate that they must have a geometric horizon arguing for two. And every time it comes up, there's one horizon on screen. Because by definition, there's only one point where the sky can appear to meet the ground. Not 2 points where the sky appears to meet the grounds. It's just it's totally non sequitur. They know they're screwed at a base level, but at the forefront of their mind is argue for a non-geometric horizon, because that's the problem here. It's like, argue what? For not having one? Welcome to Flat Earth.
They need physicality, Nathan, and they don't got it.
Physicality is the basis of their religion and their assertion that we're on a ball. A physical ball. With physical geometry, physically obscuring boats, physically bending into a circle when you go up and take pictures from a sky vacuum that violates natural law. It needs to be a physical edge of a sphere, and that's why we were charged with having an edge to the flat earth we don't represent in our model that the Flat Earth Society gives everybody. Boats going over the edge of it. Why? Because they've got a geometric edge for boats to go over, and it's an absolutely devastating part of their model that fails on its arse. Black Swan.
I think even the math debunks the geometry.
Oh, there's always pseudo-Riemannian force space. It can move in with gravity. Can always move in with gravity next to the geometrical curve, and they can all be in this cozy conceptual medium where anything is possible.
Sorry, Owen, you're wrong. There is no geometrical curve, remember? Even they state that.
Well, I think a geometrical curve still works in a pseudo-Riemannian force space. You know?
You want to conceptualize it, Arwin? You can.
Exactly. But yeah, as for the actual physical reality, the geometrical curve is, history.
Makes you think of a doodle sketchbook when these guys talk.
Hey, Nathan.
What's up, Chris?
Hey, guys.
Hey, Chris.
Hey, I wanted to add to Bab's presentation. So I was looking at the video that he sent, and so first of all, I don't think he was quite clear that you will never. I'm hearing an echo. Sorry. You will never have a convex water meniscus. It's not physically possible. The top layer of that water is flat. It's not curved or in a convex shape. The edges will have a little bit of that shape, but it's only ever on the edges, never in the middle. And when you have that tube of liquid, you will never get a convex meniscus with water. You can only get it with something like with a heavier liquid like mercury that has obviously different chemical bonds to it. And then the other thing, first of all, the Erebus guy did this, so that should tell you something. And the second thing is when you watch the video, he lowers the camera to where the edge of the bowl blocks out the light. So it's a terrible test and demonstration to begin with. But even if he did it right, you will never have a convex water meniscus. It's not possible.
Cool. Thanks. Couple of quick shout outs. Shout out to James Richard. He says, the flat horizon is the basis for the angle to the celestial object. Thank you very much for the super chat, James Richard. And also shout out to Sean Tibbets for the super sticker. Flat. Thank you very much. Really appreciate your support.
Guess what?
Go on.
Earth is flat.
Yeah, you beat me to it.
Go on.
Yes, sir.
In the gym. Soon the media panels are going to have to show Earth is flat because they're getting demolished with their own media.
Right, the Mark Sargent interview. I finally got to look at it. It was really astonishing. I didn't expect it would take that kind of turn, but I did notice that at the very, very, very end, it seemed like the host that rounded it out was kind of going with it, and then somehow this really sarcastic, bitter tone kind of sneaked in the back. Did you notice that as well? In the back of his tongue? A little? So
He wants to keep his job.
Right, but you did notice it, right? That wasn't just me?
No, it was there.
Okay, right. So it wasn't... It almost showed itself like it was being literal, but in the end, it kind of they kind of dropped their mask almost for a second, just to show like, yeah, actually, we are all sarcastic here, sort of, or potentially. I don't know. It was weird.
So just give you a quick example of Fundy Globehead doublespeak liars. So the rumpus from the chat. 3 years ago, you had it explained to you that the apparent, in capitals, horizon is not, in capitals, the geometric horizon, caused by two things. 1, Earth's geometry. 2, refraction. So this is doublespeak, because if the apparent horizon is based on geometry, then you'd need a geometric horizon to base it on, and we don't have two horizons. So you can't base an apparent horizon on a geometric horizon if you don't have a geometric horizon to base it on. Second problem is your refraction is also based on the geometry, 7/6R, terrestrial or standard refraction. And those also are based on having a physical geometry and a physical geometric horizon. Also, Rumpus is a liar, because when he came on the show, I've got a nice clip of it, he charged me with going back 3 years, maybe a bit less, 2.5 years, to any debate during the Isle of Man where he makes it clear that the apparent horizon's based on the geometric horizon, and he does not. I trimmed it out and demonstrated he's a liar because he describes things moving with respect to the horizon. So he's an outright liar doublespeaker. You can't base a geometric horizon on a physical point to give you a non-physical point because you no longer have the physical point to give you the geometry. It's just the height of doublespeak. So you don't have a geometric horizon. I'll read it slightly differently. It was explained to you that the apparent horizon, so the apparent horizon, the one that's apparent, the one that we see, is not the geometric horizon. So the apparent horizon, the one we see, is not the geometric horizon. So we're not seeing the geometric horizon, Rumpus. We don't have a geometric horizon to see. Surely we would if we were on a sphere. It would necessitate a geometric horizon. That's a factor of geometry. It's something that you've been asserting for years. But yet you're saying we don't see a geometric horizon. Well, you would if you're on a sphere. It's in your model marked with an X and called the horizon. But according to Rumpus's latest statement, it was explained 3 years ago that we don't have a geometric horizon. We don't see one, we see an apparent in capital letters. I see. So your apparent, in capital letters, sizes are also accounted for in the mathematics, are they? It's a mathematics of apparent nature, is it? Oh no, my bad. calculator doesn't have any apparent sizes. Apparent sizes in capital letters. It only deals with actual sizes. The apparent nature, obviously a much bigger consideration, is how much smaller things get into the distance. That's far more apparent. But your calculator doesn't deal in apparent in capital letters, now does it? It deals in actual sizes. 10-foot wall's a 10-foot wall, regardless if it's a million miles away in your model. The apparent size is always 100 feet, even though it's not. Apparent size would be an angular size, not a feet and inches size. So your apparent sizes are totally devoid in the calculator. You don't have apparent anything in your calculator. So why are you babbling on with this redundant term, Rumpus, about how apparent things are when your calculator's not dealing in apparent anything? Also, if your declaration is to be believed, we don't see a geometric horizon. Well, we should. If it's asserted we have a geometric horizon as your model's claiming, we definitely don't have two. So it's game over and checkmate, Rumpus, you little weasel.
By Rumpus's words, correct.
On the globe Earth model, the horizon that we see is the geometric horizon based on refraction. But what is the horizon on flat Earth? Why do we see a horizon on flat Earth?
Now, that's a contradiction in terms. You can't have a geometric horizon based on refraction. If it's a geometric horizon based on refraction, then you need to have a geometric horizon to base it on. And if the horizon we see isn't geometric, where are you getting the geometric horizon to base the apparent horizon on? It's complete doublespeak, especially as apparent is redundant. All horizons are apparent. The geometric assertion of an Earth curve horizon is apparent based on height. So they're all apparent. Adding this extra redundant term to give you a second horizon is nonsense and redundant. All horizons are apparent. Their model has a geometric horizon. It's apparent based on height. Yeah? What about in the Isle of Man? How long did we argue about how refracted that horizon was? No, we didn't, did we? We argued about 6 straight weeks solid about Antony's height. Why? Well, because it's apparent based on height, so it was the most critical detail. How high is Antony? Right? How high is he to that tangent you're going to draw to the physical, geometric obstruction blocking the beach? Right, fundies? And what's that
Singular.
you say? It's apparent. Apparent? What do you mean apparent? Yeah, we know. Apparent based on height. What's that you say? Apparent based on geometric refraction? Well, you'd need some geometry first. And if it's apparent, you haven't got it. You'd need a geometric horizon to base geometry on. What kind of nonsense doublespeak is this? You haven't got a geometric horizon. We haven't got geometry to base refraction, to base an apparent horizon on. It's completely circular. Morons.
How do you validate a geometric horizon when all horizons are refracted?
You don't. We don't have a geometric horizon. It's game over. You need one. It's there in the model marked with an X, with the word horizon next to it. It's the assertion they've made for the last 5 straight years, that a physical obstruction called the horizon has got boats going over it being obscured from bottom up, blocks the bottom of the Isle of Man. Where's the beach, they asked? How high is Antony, they asked? Argued about it for 6 straight weeks, so they could get a nice tangent line to the physical 170-foot wall between us and the Isle of Man that was claimed. No refracted horizon. Is it a 170-foot wall? Yeah, it's blocking that beach. I bet you wish you hadn't argued for 6 straight weeks about Antony's position to get the apparent height to the tangent line you're going to draw to the physical obstruction you now all deny. It's pathetic. And you're all liars. Nobody was telling us how refracted that 170-foot wall was, I assure you.
Right, so we know that the
if
geometric
Rumpus could do us a
horizon
favor
isn't
and
real.
maybe pull out where he was trying to tell us about his apparent horizon and geometric, because I've got a pretty good memory. I don't remember him ever arguing that.
Yeah, I even remember him telling me it's not optical. It's not perspective.
Right. It's physical, right?
Yeah, it's not apparent
back in the day.
sizes. It's not perspective. It would be apparent. Their sizes would be apparent if it was the apparent nature they were dealing with. And they've made it absolutely clear in the debates that they're definitely not dealing in apparent sizes. It's a geometric calculation. Why the hell would they deal with apparent sizes in a geometric calculation? That's what they told us. I'm sure a few keen fans of the show will be out there foraging for some of these devastating claims. One of which being me saying, so you're saying there's a 170-foot wall on screen right now between us and this lighthouse? Yep, that's what we're claiming, all right. A physical geometric obstruction, ignoring the apparent size, of course, because the apparent, in capital letters, isn't dealt with in their calculations. It's physical geometry. That's what they're dealing with. The claim that an Earth curve obstruction called the physical horizon's blocking the beach. So we better know how high Anthony is. Because the horizon in their geometric model's apparent based on height. What's that you say? There's also an apparent horizon? No, that's redundant. The geometric horizon's apparent based on height. They argued about it for 6 straight weeks.
Yeah, from my memory, they were even calling it the bulge, right? There's a bulge
Why do we see
that we're looking at.
anyway?
Yeah, the bulge. And for some weird reason, it got removed from MITWEST calculator, stopped being there. Stopped being called the bulge. I don't know why they'd removed the physical obstruction known as the horizon, a geometric obstruction that isn't there anymore, that's being debunked left and right by black swans.
Don't forget, Bob.
Why do we even see a horizon in the first place? Why do we see an apparent horizon?
It's diffraction limit. Or physical atmosphere between you and your target obscuring your view, like fog. If the horizon was a physical geometric obstruction, however, you could only ever bring that horizon closer. You couldn't take it further away. It's a geometric certitude in terms of where its limits lie, based on the physical geometry of a claimer on a sphere. But it could be closer.
Right. I've heard that the horizon is a result of a vanishing point. I don't agree with that particular definition. Do you guys agree with that?
On perfect, yes. In perfect scenarios, yeah. So you've had it calculated once. I've seen it done once. So yeah, it's an oversimplification for me to say you're reaching the diffraction limit. That's not true. That's oversimplified. If you take an example like Red Pill Philosophy's example that was taken to pieces by Life is Short, that was the perfect conditions, calculable only with the Rayleigh criterion. In other words, even at that perfect, you can see basically everything, totally crisp day, atmospheric conditions are perfect, sea temperature perfect, everything's perfection. You still have the angular resolution limit. And that was one of the few examples that you could say, hey, this is where we can actually calculate out how much is being, how much is in that limited, whatever it is, 0.1 angle in his lens based on the aperture, based on the Rayleigh criterion. Still calculable, still there, but that's in the perfect example. Most of the time, there's other things that are going to interfere with it. Everything that Ranty covers, basically.
Right. Okay.
But because we've got zoom cameras, seeing a black swan horizon isn't as difficult as people would have thought, and it's a game over example because you know the zoom cameras before left you arguing about the refracted nature of things being brought up to with respect to the horizon. That's what you end up arguing about, the target, not the horizon itself. Now we can say, well, you don't need things that far away. If you're quite low to the ground, the physical geometric nature of the horizon would be get closer. Well, you've only got to put something a few miles away off the shore. You could do that with a camera phone. So there's going to be people out there capturing black swans all over the place.
Yeah, it's going to be very problematic for the belief in a geometric horizon, which, as proven by the black swan, is a belief, a concept, what was it? Thought experiment?
Thought experiment, according to Andrew Thomas Young, yeah.
Yeah, that sucks. Can't have actual dimensions in a thought experiment, guys. Sorry.
I was saying it's a thought experiment that requires some geometric considerations. Geometric meaning physical, actual. But whilst you're doing your thought experiment, you'll be thinking about it being physical and actual with geometric consideration, according to Andrew Thomas Young.
And according to Brenda yesterday, let's remember when I asked her, is the geometric horizon physical? And she said, no, it's mathematical, pretty much. So, yeah.
There's going to be plenty in people's hard drives. I mean, National Geographic had one. Aren't they lucky? So those black swans are already out there.
I love how National Geographic kind of just debunked themselves with that. Oh, look, the flag is disappearing because of the horizon. Oh, what's that behind that? Oh, there's the horizon. Oops.
But it also gives a lot of assistance to the people out there that are getting long distance photography that doesn't look great. You know, it's not an oil painting at the end of the day. It's not going to look fantastic. And National Geographic's presentation was no different. They're just the same quality as everyone else that's out there on the circuit doing this with their cameras, which are probably the same camera they used. P1, I think probably would have been a P1, would it have been a P1000 back then or P900? Either way, you know, they're using basically the same equipment. So they're getting the same fuzzy images and the same, you know, low resolution at maximum zoom. That's what you get, you know, so far better to have go on, sorry.
And all they really did was prove our point that you can have bottom up, you know, disappearance due to, you know, something other than Earth curve, because that horizon is not there. So that obviously can't be the curve or the geometric horizon, as we call it now.
So angular compression.
Oh yeah, yeah. Maybe a
Are you
little
guys talking
refraction
about that
or
same National
angular
Geographic
resolution limit,
documentary
stuff like that. But
where they
obviously
used a
that's not the
helicopter?
curve.
Because that
Sorry,
one was
man.
scripted. It was 100% staged.
Yeah, they all are, but I mean, this is the one that Mark Sargent and Patricia Steer and a few other flat earthers took part in.
Was it the Salton Sea experiment?
No, I don't think so. Maybe someone can fill me in. It was at a lake.
Hey, Nathan.
Anybody remember
you
what
can
lake
put
it
up-
was on? Sorry. Go ahead, 10th man.
Oh, I got a little picture in Master B if someone could post it. Seems like the Black Swan has got a body count.
Okay.
It's like you're buzzing a fly.
Like a bug to the light.
Hey Nathan, I'd like to present something.
Hang on.
Okey-doke. I've got it on screen, 10th man.
Oh, okay. Good.
Sorry, I didn't.
Bzz. Right, go ahead. Was it Babs or Chris?
Yeah, it's Chris.
You want to?
So I just want to. I'm sorry. I just need to take it back to the convex concave water meniscus thing. So I went to my kitchen and I did a little test, just to put this to bed, and debunk Erebus. You know, pretty much straight away. So let me do a screen share here and I'll show you.
Chris Barry, ladies and gentlemen. One of the best guests.
Yeah. Yeah. So let me know when you can see my screen here.
Yeah. Go ahead.
All right. So as I said, what you can see here is I have a cup, my wife's friend's cup, and it's just a coffee mug, nothing special. And what I did is I filled the mug with water up to the very top. And then what I did is I started adding in pennies, basically anything to add mass and weight to the water. What that will cause is obviously the extra mass will start to push the water up, and you can form your own meniscus layer of water in any cup or any container, really, if it's, you know, obviously size and all. But so what happens is, and as I said earlier, you will form on the edges, and you can see it here. It's really hard to get a clear shot with the lighting and stuff, but on the let me just do a little line right around. It starts about here.
You can see
and,
it.
You know,
you can see it. There's a specular reflection
there's
in the center of it.
Exactly. But the catch is, again, and I said this, the top portion here is perfectly flat. I mean, it's as smooth as glass. And in fact, you can see the reflection of this paper towel roll in my kitchen here on the water. So it's not, the point is, again, yeah, the edges will have this slight bend, but the top is perfectly flat. and it always is and always will be. And then this is a side-on angle. Again, can't get a good, angle. It's hard to get an angle in my kitchen. So it starts about here, and as you go across, and again, with, the quality of Microsoft Paint or whatever is terrible, but you get the point. It's perfectly flat across the top.
Yeah, there's only water tension on the sides though. That's why.
That's right. Yeah, I just wanted to make sure everyone's aware of that. So again, it starts about there on the sides, and then the top is as smooth as glass. So that was it.
Perfect.
Thank
you to Chris, and I'll say if you are watching this on the Nathan Oakley premiering stream, then stay tuned, as there will be an after show to follow. Unfortunately, if you're watching this live on Nathan Oakley 1980, then this is where we bid you farewell. A huge, massive, enormous thank you to all of you. Smashed the super chat, liked, commented, shared, subscribed, and all that good stuff. Of course, a massive thank you to all of today's Discord and G Plus panels for making this live show possible. Stay tuned if you're watching on Nathan Oakley, and I'll see you all in the next video.
Oh, what a day! What a lovely day!